Distinguish between mesons, leptons, and baryons. Yeah. Okay, well, here's the thing, right? These guys are, the leptons are fundamental particles, right? Okay? These guys are, they're not made of anything, right? So that's the thing, right? Okay, so there's the ones that we're familiar with, right, are the electron neutrino, right? The muon and its neutrino, the tauon and the tau neutrino, right? So another word, by the way, for a tau is a tauon, right? I think I call it that in the test just because IB tests tend to call things weird things, right? Okay, so these guys are fundamental. These guys are not fundamental, right? So a meson is a quark anti-quark pair, right? A baryon is quark quark quark, or of course anti-quark anti-quark anti-quark, right? Okay. So these that would be good enough, right? So mesons and baryons, mesons plus baryons are hadrons. They hadrons is the family that whose members are mesons and baryons, right? Okay. Now there's a big difference, by the way, between mesons and baryons, right? If you look at these, and IB doesn't require you to know this, but it's fundamentally important, right? Is that quarks have fractional, notice that they have 1/2 spin, right? Okay, so quark anti-quark, well, that's going to be 0 spin, right? Okay, so those things are going to actually be, what I think, scalar bosons. Yeah, I think but anyway, they're going to obey, these guys are bosons, right? And then baryons, I'm speaking a foreign language here that I barely know, right? Baryons are going to have 3 quarks, right? So they're going to have fractional spin, right? So that makes them fermions. Notice that the leptons also have fractional spin, so those are fermions. Right, so why should we care about this? Well, because there's 2 totally different types of mechanics that go on. There's Bose-Einstein, right, which is super cool. It involves like superfluids, and like these guys can be in the same quantum state, right? And then there's Fermi-Dirac, which is, you study a little bit of that in chemistry, right? The Pauli exclusion principle, right? So there's Fermi-Dirac mechanics, right? So all these non-integer spins are going to be totally different interactions. And I sound like I know more than that, but I really don't. I studied it once, but anyway, there you go. Okay, now there is a couple questions on the test. There's a question about muon decay. So look at what a muon, know what a muon will decay into, okay? I'll give you a clue on the test, but you might want to study that, right? There's also a question about particle accelerators. Why do we use particle accelerators? Okay, so study up on that, right? There's a reason why we use particle accelerators, why we can't just go out and study a tau particle or a muon. It's hard to. Why is it hard to study a muon and a tau particle? It has to do with their lifetime. Okay. I think we've answered this question.